In this video, we're going to look at the questions from exercise 2A. And all of these videos are based on our 4 equations that we've looked at in the intro. So this equation has V, U, A, and T. This one has V, U, A, and S. This one has S, U, T, and A. And this one has S, U, V, and T. So obviously, in any of these equations, we have to be given 3 variables to get the fourth. So these are really straightforward questions in exercise 2A. A car accelerates uniformly from rest. So anytime you see rest, just jot down that the initial velocity is 0 to 10 meters per second, which is my final velocity. In 5 seconds, t is equal to 5. So we have 3 variables. All we need now is to look at what we're asked, find the acceleration. So we need to go to an equation that has u, v, t, and a, and you can see it's the first one here, u, v, t, and a. So v is equal to u plus at. 10 is equal to 0 plus 5a. So a is equal to 2 meters. You can say either ms, meters per second squared, or ms to the minus 2. And I probably use both within these questions. So what else are we asked here? The distance covered. So now we have I'm going to put my a in here. A is equal to 2. So we're looking for a distance formula. So you can see here we can use this one, or we can use this one. Let's have a look at both. Can we use the top one as well? Probably use the top one as well. Let's go down. V squared is equal to u squared plus 2as. So my 10 squared is equal to 0 plus 2 by 2 by s. So 100 divided by the 2 2's are 4 will be equal to s. So s will be 25. So we might look at it. Let's use the second one. V squared is equal to u squared plus 2as. 10 squared is equal to 0 plus twice. Well, actually, it's the same one again. What am I doing here? So the third one, s is equal to ut plus a half at squared. So s is equal to 0 plus a half times 2 times t squared, which was 5 squared. So s is equal to 2 25s are 50 divided by 2 is 25, and these are in meters. And you can see we could use the last equation as well. So write down your variables, figure out what they're asking you, fill the information into the formulas. Question 2, a car driving on a straight road accelerates with an acceleration of 3. A is equal to 3. From rest, u is equal to 0 to a speed v of 24. V is equal to 24. Find the time taken. So you should have the formulas all written in front of you. So write these formulas out on one page. Have them in front of you until you learn them off by heart. They're not, you will learn them off by heart in a week or 2. So v is equal to u plus at. Will help us here. V is equal to u plus at. So 24 is equal to 0 plus 3t. So you can see here t is equal to 8 seconds. And then the distance covered, s, we have just put down here, we have t as well. There's 5 unknowns. We now have 4 of them, so we can use either of the s formulas. S is equal to ut plus a half at squared. Could be one of them that you could use. So s is equal to 0 plus a half by 3 by 8 squared. You could write 64 in there if it helps. So we have half of 64, which is 32, times 3, which is 96 meters. On to question 3. The car starts from rest and accelerates. A is equal to 3. It starts from rest. U is equal to 0. Speed, so v, when it's traveled a distance s of 6. S is equal to 6. So we're looking for v here. V squared is equal to u squared plus 2as. Is one of the ones that we can use here. V squared is equal to 0 plus twice 3 times 6. V squared is equal to 36. So v is equal to 6 meters per second. On to question 4. A train accelerates from 50 to 70. So that means its speed was 50, then it became 70 over a distance of 300. So we have S is equal to 300, U is equal to 50, and V is equal to 70. And we're looking for A. V squared is equal to U squared plus 2AS. V squared is equal to U squared plus 2AS. We could also get the time here. We have V, U, and S. We could say V is equal to U plus AT and get the time. 70 is equal to 50 plus A, which we don't have. We don't have the time either, so actually we can't use that one. Can't use it yet. So let's get the acceleration from this one. V squared, 70 squared is equal to 50 squared plus twice 300 by A. So we have 4900 minus 2500, which is 2400 divided by 600. So that's going to give me A. So that's going to give me A to be 4. 600 is 2400. So A is equal to 4. And then my time is going to be 70 plus 50 is equal to 4t. 4t is equal to 20. So t is equal to, in this case, 5 seconds. Question 5. Car accelerating uniformly. A is equal to 0.5. And here's the ms squared, which is the same as meters over second squared. And you can see if you bring the inside up, it's the same as ms to the minus 2. So both are the same. A distance of 600. S is equal to 600. T, 40 seconds. T is equal to 40. So what was its initial speed, V? So we don't know what V here is in question 5. Sorry, initial speed U. U is the initial speed, obviously not V. So what can we use here? S, we have SUAT. S is equal to UT plus a half AT squared. Now if you choose the wrong formula, just go back and choose the right one. So 600 is equal to, we're looking for U. So we're going to have 40 times U plus a half times a half, 0.5 is a half, times T squared, which is 40 squared. Now I'm just going to write 1600 here. So you can see 600 is equal to 40U. And this is a quarter of 1600 plus 400. So 40U, that's a U, is equal to 200. So in this case, the initial speed is equal to 5 meters per second. Question 6. Cyclist accelerates uniformly from 3 to 11. So U is equal to 3. V is equal to 11 during a 6-second period. T is equal to 6. So we're looking for distance covered. So we get a couple of ways to do this. We have V is equal to U plus AT. We can get the acceleration if we need, and then we can get the distance. Or, well, let's do that. Let's try it that way. I'll do it 2 ways. I'll do the fourth formula, S is equal to U plus V over 2 as well, times T. It's probably not as commonly used as some of the other ones, so I'll do it here for this one. So we're looking for the distance. S is equal to 3 plus 11 divided by 2 times 6, which is 14 over 2, 7 times 6, so S is equal to 42. So that's obviously the quickest way to do it. You can also use V is equal to U plus AT. I'm just showing you the multi-use, that even if you pick a formula that requires another bit of work, it can still be done quite easily. So V, a final velocity 11, is equal to my initial velocity plus 6A. So A is equal to 11 minus 3, which is 8 over 6, which is 4 over 3. Now we weren't asked for the acceleration, but we could be asked for acceleration and distance. So maybe good habits to get into to find all 5 variables if we can. So now we could use S is equal to UT. A is 4 over 3. UT, we're looking for distance plus a half AT squared. So my distance is equal to U, 3, times T, which is 6, plus a half by 4 over 3 by T squared, 36. So S is equal to 18. And we have here, we have a 6 on the bottom, which divides into my 36 6 times. 6 times 4 is 24. 18 and 24 is also, of course, the 42 meters that we already got. Question 7. A lift decelerates from 3 meters per second to rest. So my initial speed u is 3. And my final speed, rest, v is 0. During the last 6 seconds of motion. So t is equal to 6. And we're looking for a here. And I've misread this, 6 meters of motion. So my s is 6. So v squared is equal to u squared plus 2as. 0 is equal to 3 squared plus twice my acceleration, which we're looking for by my distance. So you can see here that 12a is equal to minus 9 because it's slowing down. So a is equal to minus 9 over 12, which is equal to minus 3 over 4 meters per second squared. And now we're looking for time. So we have a minus 3 over 4 time. So we can use any of the formulas for time. V is equal to u plus at. V is equal to u plus at. So we're going to get v, which is 0, is equal to u, which is 3, minus 3 over 4 times t. So we're going to get 3t over 4 is equal to 3. 3t is equal to 12. T is equal to 4 seconds. So now on to question 8. See, these are quite easy. There's a lot of repetition here. A train slows down from 70 to 50, the opposite of the previous one. So u and v. U equals 70. V equals 50. Find deceleration over an 8-second time interval. So this one is the t. T is equal to 8. Find deceleration and distance. Okay, let's have a look at deceleration. So looking for a, v u a t. V is equal to u plus at. 50 is equal to 70 plus 8a minus 20 is equal to 8a. So a is equal to minus 20 over 8, which is equal to 4 goes into both, so minus 5 over 2. That'll be meters per second squared. And we're also told if the train continues to decelerate over the same uniform rate, how much further, so we're looking for distance, will it travel before it comes to rest? So that's when my v will be equal to 0. So the initial velocity hasn't changed, u is equal to 70. So we have here how much further, so we're looking for, and we also have the same deceleration, minus 2.5. v squared is equal to u squared plus 2as. 0 is equal to 70 squared plus 2 by minus 2.5 by s. So we're going to get 5s is equal to 4900. S is equal to 4900 divided by 5. So s is equal to 1000 less 20. You get my total distance here. My u, it started at 50, didn't know we were going from 50. So 50, gone too quick here, 50. So 5s is actually equal to 2500. Now, I was just looking at the total, and we'll go back, and we didn't get the distance in part 1, but I could have worked it out doing this. But let's do what they've asked. So 2500 over 5, which is 500 meters. Read the question carefully. So the distance covered in part 1, which I skipped. So now we have a is minus 2.5, and we're looking for s. So we can use s is equal to v plus u over 2. S times t. S is equal to u plus v over 2 times t. So the distance covered in this part is s is equal to 70 plus 50 divided by t. Divided by 2 times t, which is 8. 120 divided by 2 is 60 times 8 is 480 meters. And we were looking here, we were going to get 4900 divided by 5, which is your 980 meters that we could have kept going with and then worked our way back to this. But read the question carefully and do what they ask you. Question 9. A car max deceleration of 8 meters per second. Deceleration, A is equal to -8. Find the shortest possible distance it will take to stop traveling 24. Okay, we'll just look at the first part first. A is equal to -8. Now we're asked to stop, so that's rest. So that's my final velocity because it's moving at the start, and u is equal to 24, and we're looking for the shortest possible distance here. So s. So s, u, v, and a. Leads us to v squared is equal to u squared plus 2as. Now you could simplify this down, manipulation of formula. V squared minus u squared divided by 2a is equal to s if you wanted, but I never have a tendency to do this. I just fill the information into the formula. 0 is equal to u squared 24 squared plus twice -8 times s. So this is going to be a -16s, but it's going to be 16s. So s is equal to 24 squared divided by 16. And that is going to give us 576 divided by 16 works out evenly to be 36 meters. For my 48, a is equal to -8, v is equal to 0, u is equal to 48, and s is equal to, if you want to use this one, v squared minus u squared over 2a. So s is equal to 0. Minus, now we could put in plus numbers here if you wanted to avoid this minus messing around. So minus u squared is going to be minus 48 to be squared and divided by the 2 by the -8. And this is why I don't really use this one, is that we just bring in minus signs that are unnecessary. So 48 squared is 2304 divided by 16. That gives me 144 meters. Question 10. Convert 72 kilometers an hour to meters per second. Okay, well 72 kilometers is 70,000 meters per hour. So if we want to get it per minute, we divide by 60. And if we want to get it per second, we divide by another 60. So 72,000 divided by 3600 is going to give me 20 meters a second. Now we're told a train decelerates from 72, my initial velocity is 72, to 48, my final velocity is 48, over a distance of half a kilometer. So my distance, I'm going to write in meters, 500 meters. We're asked to find deceleration, A, as a fraction, and also the time taken, A and T. Now I presume they're asking us, because they've asked us 72 here, they want us to convert 48,000 as well, divided by 60, divided by 60, 48,000 over 3600. It's going to give me 13 and a third. Okay, let me do it this way first, and we'll see, do we get a fraction? So A, V, U, A, S, V squared is equal to U squared. So we're looking for how much further? So we're looking for S plus 2AS. So 48 squared is equal to 72 squared plus twice 500 times S. So S is equal to, not SA, A is equal to, it's going to be negative, it's slowing down, so A is equal, that's 1000 A. So we're going to have 48 squared minus 72 squared divided by 1000. So that's going to give me, now look what I've done, this is kilometers an hour, I'm trying to go too fast here, and this is 500 meters. So I'm going to go back and actually use those fractional numbers that I got there a second ago. think it works out a bit neater than this one. Okay, so we'll take my V as 20 squared, because you have to keep the same units. You can't be using kilometers and meters in the same question. That's equal to 13 and a third squared plus twice my distance of 500 times my acceleration. So we're going to get 20 squared. No, it's the other way around. We're going to get, put my using these the wrong way around here. 13 and a third squared is equal to 20 squared. So I'm going to get my acceleration to be 13 and a third squared. I'm just going to type this into a calculator. Minus 20 squared divided by 1,000. That's equal to A. So a bit messy here. A is equal to, as a fraction, minus 2 over 9. It's given me on a calculator. So time, we could use V is equal to U plus AT here. V is equal to U plus AT. So my final velocity was 13 and a third. My initial velocity was 20, and that's minus 2t over 9, or 2 over 9t. So we're going to bring 2t over 9 to the left, and we're going to have 20 minus 13, 6 and 2/3 left. So if I multiply 6 and 2/3 by 9, I'm going to get 9 sixes are 54, and 18/3, which is 6. I'm going to get 60 divided by 2. So t is going to give me 30 seconds in this question. Anything else in this question? If the train continues to decelerate, find how much further, so we're looking for s, it will travel before it comes to rest. So like the previous question where I took the wrong velocity, u is equal to what it's at now, 13 and a third. It's coming to rest at 0. A is equal to minus 2 over 9. And I can use, we're looking for s. So I can use v squared is equal to u squared plus 2as. 0 is equal to 13 and a third to be squared plus twice minus 2 over 9 by s. So I'm going to have 4s over 9 is equal to 13 and a third to be squared. So I'm just going to multiply that by 9 and divide it by 4. And I'm going to get s is equal to 400 meters. Okay, hopefully you've gotten most of these correct. Question 11. Show that a speed of 1 kilometer an hour is equivalent, right, to 5 over 18 meters per second. 1 kilometer an hour is 1,000 meters per hour. 1,000 divided by 60 times 60 is going to give me, crossing out my zeros, 10 over 36, which is equal to 5 over 18 meters per second. The speed of a car is reduced from 72, so you can see here, don't get cut out again, over a distance of 35 meters. Right, so it's stopping really quickly here. I have 72 kilometers an hour from the previous video. That's equal to 20, and it's coming from, if you have 1 kilometer an hour, so we have 1 kilometer is 5 over 18, so 72 is going to be 72 divided by 18 even, which is 4 times 5, which is 20. So that's my 72. That's where the 20 comes from. And the other one is 54. 54 by 5 over 18 is 3 5s, which is 15 meters per second. Meters per second, because I have meters here. Okay, so now I have my initial velocity. We're looking for retardation or deceleration. So we're looking for A. We have U is 20. We have V is 15. And we have the distance S is 35. V squared is equal to U squared plus 2AS. So look for A, V, 15 squared is equal to A, 20 squared plus twice 35 times s. So 225 is equal to 400 plus 70s. So we have minus 175 divided by 70 is equal to s, and 270 is 140, lays 35. So that's going to be s is equal to minus 2.5 meters per second squared, or ms to the minus 2. Okay, if the retardation continues, how much further will the car travel before coming to rest? Not much room here now. Okay, if the retardation continues, a is equal to minus 2.5. We know we're now at 15. So my initial velocity is 15. My final velocity is rest, which is 0. And how much further it will travel is s. V squared again is equal to u squared plus 2as. So 0 is equal to 15 squared plus twice minus 2.5 times s. So 5s is equal to 225. S has to be then 225 divided by 5 is 45 meters. We're nearly there with this one. I know I said I'd keep the video short, but this one's going a little bit over my 20-minute max. P and Q are points 162 meters apart. Just do a little sketch of that, it might help us. P and Q are 162 meters apart. This is where we're looking at the distance, one going this way and one going this way. So whatever distance P travels, we'll call S1, and whatever distance Q travels, we'll call S2. And when they meet, obviously they've traveled, even if Q has only gone 1, P will have gone 161 and so on. So the distances added together, which comes up a lot, is going to be 162. So let's look at P here. Initial speed 5. Uniform acceleration, A is equal to 3. Q, initial speed 7. And uniform acceleration 2. So you can see here we're short of variables. So what we do is we create two equations and we add them together. And the answer is going to be 162. And distance is what we've been given. So S is equal to UT plus a half AT squared. The unknown is going to be T. So we'll call this S1 for P. S1 is equal to 5T plus a half by 3 by T squared. So distance 1 is equal to 5T plus 3 over 2T squared, or 1.5T squared if you'd prefer. Q, S2 is equal to UT plus a half AT squared. I think it's good maths just to write the formula down just so you don't make an error. 7T plus a half times A, well that's a half times 2, I'll write it down so you can see it, times T squared. So S2 is equal to 7T plus T squared. So we can say here that these two equations added together are going to give me 162. So let's do that and find the time they meet. So S1 plus S2 is equal to 162. So we're going to get, what do we got, 5T and 7T. We'll put the T squared first. T squared and 1.5T squared. So 2.5, 2.5T squared. Then I need to multiply that by 2. 2.5T squared plus 12T. I'm going to bring the 162 across. So we're going to get 5T squared plus 24T minus 324 is equal to 0. Does this factorize for us? Let me see. 5T times T, it has to be because it's prime. Now, factors of 3, 2, 4. We'll be there all day writing them out, but we want to get back to 24. So we need a difference of 24 here. 650s is 300. 654s, I think. 654s. That you can see there. That's going to work. 6. That's going to give me 30 and 54. And I want to get back. I want a positive 24. So T plus 54T plus and minus 30. So you can see here there's only one solution that works. Time can't be negative. So T is equal to 6. So they meet after 6 seconds. So to find the distance traveled, we can put it back into any of these equations. Are we asked for distance here? After how many seconds did they meet? Okay, we have that. And the speed of each body. So we're not looking for how far P has gone and how far Q has gone. That'll probably be in one of the next questions. So the velocity, if we look at P on its own, we have my initial velocity is 5. We're looking for V. My initial velocity is 5. My acceleration is 3. And my time is equal to 6. V is equal to U plus AT. V is equal to 5 plus 6 times 3. 18 and 5. The velocity is 23 meters per second. That's for P. For Q, we have 7 and a 2. V is equal to V. U is equal to 7. A is equal to 2. And again, T is equal to 6. So V is equal to 7 plus 2 times 6. 12 and 7. V is equal to 19 meters per second. For Q, that's the end of that one. What question was that? 11? 12. Okay, 13. And I think I've left 14 out for a future examination question for you guys. So this is question 13, the final one in this video. X and Y are 400 meters apart. You can see it's the same type of question. Okay, so let's do a little diagram. X and Y, it's the same as the last question. We just asked this extra bit here, which is just written down, the distance as well. So we have X, we have Y, the distance is 400. So S1 or Sx plus Sy, S2 is equal to 400. X is traveling towards Y. So here's my X with initial speed 3 and acceleration 4. At the same time, Y is traveling towards X with initial speed 7 and acceleration of 2. So S is equal to UT plus a half AT squared is what we're going to use here. So S1 is equal to 3T plus 4T squared. And S2 is equal to 7T plus 2T squared. So we're going to have 6T squared. So what have I left out? You're all saying, where's that half gone? My mind is boggled at doing so many of these questions, right? So a half AT squared. So it's going to be 3T plus a half by 4. So it's obviously going to be plus 2T squared. And maths is also about identifying your mistakes as you're making them. So always just check back a couple of lines each time. So 7T plus a half AT squared is 7T plus T squared. So I'm going to get 3T. I'm going to get 10T plus 3T squared, or 3T squared S1 plus S2 plus 10T. Now I'm going to write equals 400, but instead of doing that, I'm going to write minus 400 equals 0. So 3T times T, it has to be 400 could be 40 by 10. That works for us here. You can see that 40 by 10. Take the most obvious one to check first. And we're going to have 40 minus 10. So this doesn't work. So the time taken before they meet is equal to 10 seconds. So the distance traveled by each, S1 is equal to 3 by 10 plus 2 by 10 squared. This should work out for us. So 30 plus 200 is 230. So the other one has to be 170. Let's double check. S2 is equal to 7 by 10 plus T squared, which is 10 squared, which is equal to 170. And you can see here, if you wanted to double check your maths, 170 and 230 is 400 meters. And write the meters down as well. So that's this question. I'm going to leave question 14 out. I'm going to give you a class test on it. So if you get to the end of this video, you've been given a hint. So good luck practicing these questions.